Now from this video onwards, we are going to learn another new data structure which is called MaxHeap, or sometimes alternatively it is called a priority queue data structure. So what is a MaxHeap or priority queue? It is basically a special type of binary tree where the data items stored at the parent node is larger than both of its left and right child. So here comes the notion of the priority. By seeing this relation, it seems that the priority of the parent node is larger or is greater than both of its children. So that is why the name priority queue is given. And why MaxHeap? As you can understand, among the left, parent and right, among these three vertexes or three nodes, parent has the maximum value. That is why it is called MaxHeap. So that is the justification of the name. Now these MaxHeaps should follow another property. Here the binary tree or this MaxHeap or priority queue must be a complete binary tree. So what is a complete binary tree? A complete binary tree is a binary tree in which every level except possibly the last level is completely filled up and all the nodes are as far left as possible. What does that mean? You can easily understand it through this example in the right hand side. So the first thing, a complete binary tree where every level except possibly the last level is completely filled up. So just consider all the level until the last but one. So until here, that is the level 0, the level 1, both these levels are completely filled up. You cannot insert any other vertex in this either of these levels. So that's the first thing. Now in the leaf level, I mean in the last level, here there are several empty spots. So let me first show all the empty spots by doing a circle. So since it is a binary tree, we have an empty slot as P, the right child of P is empty here. Then left child of H is also empty. The right child of H is also empty. So right child of P is empty, both the child of H is also empty. So there are several empty spots at the last level of this binary tree. Now to make this binary tree complete, you cannot have a situation where this empty place remains empty but you put data in either of these two child. For example, let's say I want to insert an alphabet E in this node, in this binary tree. Now in order to make it complete, you cannot put E in here. That is wrong, because in a complete binary tree it cannot happen that in the same level some nodes in the left hand side will remain empty but some right node is filled up. So that is the meaning of nodes are as left as possible. So in order to make it a complete binary tree, you cannot put E in here. Rather, you have to start filling up the tree from here. So E should be put here. So let me just delete this. Now after E, let's say if I want to put some node, let's say G. Now again, the same thing. You cannot put G in this place because here this place will remain empty and that cannot happen. So in order to make it complete, you have to put G in here. So basically what you need to do is you have to start filling up the empty spot in the last level of a complete binary tree from left to right direction. So that is the notion of the complete binary tree, and in order to make a MaxHeap or priority queue data structure, the binary tree should be complete as well as it should follow this relation where parent is greater than both left and right.